Hi there. In this third part of factoring, we talk about two special types of factoring that we didn't talk about in part two. We talk about the difference of squares and the perfect square trinomial. How do we factor these? That's what we talk about here. First of all, let's talk about the difference of squares. A difference of squares is an expression that looks like what I have here on the left hand side. A squared minus b squared. So something squared minus another thing squared. That's a difference of squares. In other words, you are subtracting two squares from one another. That always multiplies or always factors into a product of conjugates. So you are going to have a minus b multiplied by a plus b. These are conjugates because a and b are the same. The only difference between them is the sign in between. That's what you call conjugates. A minus b multiplied by a plus b. A difference of squares always factors in this way. For example, x squared minus 9. You can see that this is a difference of squares because you can rewrite this as x squared, which is x squared, minus 3 squared. 3 squared is 9. So if you think of x as a and 3 as b, you can write this as a product of conjugates. X minus 3 multiplied by x plus 3. This will be the factored form of the difference of squares x squared minus 9. Let's do another example. 4x squared minus 25. Again, this you can write as a difference of squares because 4x squared you can write as 2x all squared, that is 2x times 2x. And 25 you can write as 5 squared. So if you think of 2x as a and 5 as b, you can rewrite this as 2x minus 5 multiplied by 2x plus 5. Let's do one more example. 9 over 16 x squared minus 4y squared. Again, you can think of this as a difference of squares. 9 over 16 x squared is the same thing as 3/4 x all squared minus 2y all squared. So if you think of 3 over 4x as a and 2y as b, we can do like we did previously and rewrite this as 3 over 4x minus 2y multiplied by 3 over 4x plus 2y. Then let's talk about the perfect square trinomials. Previously, we talked about trinomials, where you have a polynomial that has 3 terms in it. But when we're talking about factoring them and they become perfect squares, they look like this. It's a plus b all squared or a minus b all squared. That is something plus another thing squared or something minus another thing all squared. Will be the factors that we are going to be looking for in these ones. For instance, look at this. 4x squared plus 12x plus 9. This is a trinomial. It has 3 terms in it. To see if this is a perfect square trinomial, we will first of all rewrite as follows. So the first term, see if you can write it as a perfect square, something all squared. In this case, we can. 4x squared is the same thing as 2x squared, all squared, plus 12x plus the last term, which is the constant term. See if you can write that as a perfect square, which we can in this case. It is 9, which is 3 squared. And then the middle term, see if you can rewrite it as 2 times the coefficient of the perfect square that you're having over there, right? When you break it down, the 2. See if you can write it as 2 times 3. So that is 2 times 2 times 3. In this case, you can because 12 is 2 times 2 times 3. Therefore, we know that this is a perfect square trinomial and the factor will just be written as follows. You just write it as 2x plus 3 all squared. In other words, the factors or the binomial that you are going to square will be the coefficient of the leading term that you have broken down. That is the 2x, and then the constant term, that's the 3. Right, so that's a 2x plus 3 all squared. And if you expand this, in the way that you've learned previously, you will see that you will obtain the original thing you started with. Let's see another one. What if the sign in the middle is negative? Instead of positive 12x, you have negative 12x. All that will be happening there is that the sign in the middle, instead of having 2x plus 3, you'll be having 2x minus 3 all squared, and it will be it will factor out in the exact same way. Let's do another example. 9x squared plus 24x plus 16. Well, if you look at this the way we have said, let's see if we can write it as a perfect square. Look at all the terms in there and see if we can rewrite them. Well, you can see that the first term you can rewrite as 3x all squared. The last term we can rewrite as 4 squared, which is 16. And the middle term we can rewrite as 2 times 3 times 4x, right? In which case, it implies that we can rewrite the expression as 3x plus 4 all squared. That means it's a perfect square trinomial. And what if the sign is negative in the middle? Instead of 24x, you have minus 24x. The only difference is that you will have 3x minus 4 all squared instead of 3x plus 4 all squared. Now, one more thing. What if the constant term has a negative attached to it? Right? In that case, this will not be a perfect square trinomial with real number coefficients. We are not able to factor this. Okay, that's what that means. Okay, so if you are having a negative attached to your constant term, in whatever case, you are not able to factor as a perfect square trinomial. That's also the same thing as saying you cannot factor this. So, you try and do the following example. And like we had done previously, please pause the video now and try your hands on these, and then when you're done, you can continue the video to see what I have done. So please pause the video now. Alright, so what did you do? Here is what I did. For the first one, you can see that will just be 3x minus 2 and 3x plus 2. For the second one, similarly, that will be 2x now, 2x minus 7 and times 2x plus 7. And for the third one, similarly, you can rewrite as 4x squared minus 9x or 9y all squared, which will now break down into 4x minus 9, 4x plus 9. And for the last two, number 5, that one is a perfect square trinomial because you can break it down in the way we had discussed previously, which means that the perfect square trinomial will become x plus 1 all squared. But number 6 is not a perfect square trinomial because you can see that there's a negative attached to the constant term. Therefore, you cannot factor this as a perfect square and you can write it as 2x plus 3 all squared or 2x minus 3 all squared. So we'll say that this cannot be factored. So this concludes our video on the topic of factoring.